Hi, this video is going to talk about volume. That's one of our last topics that we talk about. And the first thing to think about is how it relates to area, right? So I'm going to write a couple of things down. You'll remember when we first started talking about area, it was basically on a geoboard. And we said area is this idea of you're counting how many squares, right, actually fit inside a flat object. So that's really what the concept of area is. Right, you're counting the squares. So volume is very similar, right? So when we talk about volume, we are now discussing three-dimensional objects. So instead of counting the squares that fit inside, we're actually counting the cubes that fit inside, right? So we're really going through and saying, let's count how many of those, right, fit inside the figure. And it makes sense to talk about that because the object that we're discussing is three-dimensional. So we can really say how many of these really fit inside. So I'm going to show you a simple example. Let's start with a very common figure that I think everyone knows about, which is the good old Rubik's Cube. Right? So if you look at this, this is a great example to start talking about the idea of volume. Because what we take to be our unit here, right, in the Rubik's Cube, would actually be one of these cubes. So when we say what's the volume of the Rubik's Cube, if we're using this as our unit, one of these cubes, then we're really saying how many of these make up the Rubik's Cube. So you can go through and count them all, right? So you can count here, if you look at the orange face, you're going to see 9 of those, right? And then in the second row here, we're going to have 9 more, and then finally 9 on the bottom, so 27. So we would say here for the Rubik's Cube that the volume is 27 cubic units. And this is our cubic unit. So that's really the idea, how it works. Now, I'm going to encourage everyone now to think about the volume in a different way, because this is going to help us understand how you can get the volume of figures that are not quite as simple as the cube. So I'll go back to the orange side. So if you take this as a face, right, of your figure, so we're looking at this. Another way of saying how do we get the 27, how do we get the volume, is let's do the area of one face, right? So if you do the area of this face, you can see this is a 3 by 3, so the area here is 9. And then if you look at the figure, the fact that it's uniform, you just ask yourself, how tall is it, right? So you can see the height here is going to be 3 cubes high. So another way you can get volume is to actually calculate the area of one face, which is 9, and then multiply by the height, right? So 9 times 3 is also going to give you that 27. So this is the idea that works as long as the figure, right, is uniformly the same as the area of this face that we're looking at. So I'm going to show another figure now, and this is going to connect to a different video. This little thing here, right, you might recall this in some of your geometry classes. So this is a cylinder. So I just took a piece of paper and I wrapped it together. So it looks rectangular here, but if you look in here, right, this is a circle. So we could ask ourselves a common question here is, what would the volume of this cylinder be? That's like asking how much would it hold, right? So how much would it hold inside? So this figure, if you look on the very top, right, is a circle, but then it is uniform all the way down just like this. So if you want to get the volume of this, this is one way that we can do it. One way we can actually talk about the formula. So if we say volume of a cylinder, and we'll do it just like the Rubik's Cube, right? So we'll look first at the area of its face. And here we talked about this in lab. So as long as we know the measurement of the radius, we would be able to get the area. So the area here is pi r squared. Right? We derived that one. And then you'd also have to know, right, just like the Rubik's Cube, how tall, right, is the cylinder. So what is its height? And we'd probably call that h. So we would take the area of the face and multiply it by the height, right? So this is exactly the same way that we did this. Take the area of one face and ask yourself how tall it is. So that's it. That's how you can get the volume of the cylinder. So the volume here is going to be the area, pi r squared, and then times however tall it is, right? The height. So in geometry books, you will often see it written just like this, pi r squared h. And notice that you can tell that the units here are cubic. Right, this is cubic units, so it's really counting the number of cubes that fit inside. The reason you can see this is the r squared, right, will be squared units, but then you're multiplying it by another unit. So this is where you get your cubic units. So that's a simple way just to understand how you can compute the volume of a 3D geometric figure.